Okay. Why don't we get started then? Thank you all for joining. I really appreciate it. Today's presentation is meant to be kind of an overview of what we have done and what we are now funded to do and some of those accomplishments, but it really is meant to be an overview and maybe an introduction to what's coming down the road in terms of these cyber seminars. And so this is a little bit of an overview. It's not a walkthrough like I know many of you are really yearning to get, but we'll start with the walkthroughs next week and continue with them in the subsequent week. All right, so this is, why don't I move on to the next, the first slide here. I guess I should acknowledge my co-PIs on the CZOData project and maybe introduce myself a little bit. I'm a geochemist, an aquatic geochemist by training, actually with a specialty in organic matter geochemistry. But I work at a stream ecology center, and I'm very much interested in the fluxes of both sediments and dissolved materials. And as a result, I guess, along with some formal training in ecology and soil science and actually a PhD in oceanography, I got very interested in integrating data. And I was co-lead PI for the Christina River Basin CZO, I guess still am. And this whole integrated CZOData project really was started by Mark Williams, who deserves quite a bit of credit. And unfortunately, he had to leave his role as leader because of some other very large projects that got funded that he was on. So I got asked to take over. The other members of the team, Kirsten Leonard from the Integrated Earth Data Applications group, she's the director of that center at Columbia University, Lamont Doherty. Ilya Zaslavsky from San Diego Supercomputing Center, and he has some staff. Jeff Horsborough and David Tarboton from Utah State University. They, along with Ilya, were some of the primary architects of Quasi's hydrological information system. And Emilio Mayorga from the University of Washington Applied Physics Lab is one of the people involved with integrated ocean observing systems, which is a NOAA-funded effort at NOAA. And I think some of them may be on our line here. So hopefully they can answer some questions. All right, definitely keep on hearing people jumping in. That's great. Some people are just calling. If you've called in, this is a web presentation, so you can log in separately, use a phone, and see the screen. All right. All right, let's move into the meat of things here. So there's a lot of motivation for doing this that's been building within the National Science Foundation for quite a while. From the very beginning of the CZO program, there was a lot of interest in integrated data management, and that has been increasing from 2006 to the first solicitation to the present. And most recently, things have really hardened with this executive order from the White House. It's no longer optional for agencies to think about open data of publicly funded projects. So this whole issue of sharing data has some real teeth in it, and as a result, NSF and Enriqueta Barrera in particular has put a lot of emphasis on and recently on funding integrated CZOData efforts. So I'm going to give you a little bit of a history. I'm going to first describe what we have now, which was built with a supplement to Boulder Creek CZO in 2009. It was a relatively modest amount of money, and that funding ended in 2011. Since then, in the last year, we've gotten quite a bit of money and are getting up to speed and have been working hard in kind of behind the scenes for the last year or so, and I'm going to describe what we've done there and then also where we're going. So this first project was, like I said, $500,000, but nearly half of that was given to support the first 3 CZOs in their data management activities, essentially a little extra money so that they could hire a data manager for the remaining 3 years of their project. There was money for a national CZO website, which is now at criticalzone.org, some data workshops, and then a relatively small amount of money to fund folks at the San Diego Supercomputing Center and at Utah State University to begin to build some integrated cyber infrastructure and a means to share data. The system that was developed in 2010 primarily and finalized in 2011 is described in this publication, which is available if you go on to criticalzone.org and look under publications, and then at the bottom of that screen, there's tags for disciplines. If you look at national data and cyber infrastructure publications, this one will be there, along with the proposals for this initial project, the one that's now funded, and some other things. So the approach that was decided on really early on, and this was really in 2009 when the second group of CZOs were just barely getting their feet on the ground. So it was really the original 3 CZOs plus Mark Williams and folks from the Quasi group decided on this approach, and we've been basically moving with it. It is to, of course, to not reinvent the wheel. The amount of money was so modest. There were lots of other activities. So essentially, the goal was to build on what existed at Quasi, their hydrological information system, the EarthChem database that is at Columbia Lamont, what the LTERs have done, et cetera. So there was a goal to present data in a consistent way on the web so that metadata could describe the data values. We're going to discuss that later. So this consistent mode of presenting data is highly important. And there would be a central data system, and maybe I should have modified that to say a central metadata catalog to help with data discovery. What is sometimes, well, I'll get into the details of that in a moment. So it's essentially a way to find data, but not a place to host it itself. So one of the initial guiding principles was that each CZO would operate and be responsible for their own local data management, for collecting, organizing, doing all the QA, and putting data on a website. That was the responsibility of individual CZOs. So this was quite a different philosophy than Quasi hydrological information system. Quasi really in Earth informatics has led in terms of trying to integrate data at the most granular level of individual data values. And there's some huge benefits to that. But it's challenging because those data have to be highly, what's the right word, harmonized in terms of the metadata and the data types and even the whole conceptual information model of how they're organized. So that was a really high hurdle. So we decided that each CZO would be the master of its own data. This is not unlike what LTERs have done, but we've taken it one step further, or kind of tried to begin to bridge that difference. So at the national level, we don't care what goes under the hood in terms of your local data management at individual CZOs to some extent, as long as the data get made publicly available in a format that we've all agreed on. So every site uses their own protocols, their own database systems, et cetera. And of course, this allows, honors the fact that every one of these sites already has legacy data and legacy data systems. So this is where we try to harmonize and integrate the data. Each CZO, we agreed, would publish its data on the web in formats that could be archival, that is generally ASCII text format, and with sufficient metadata so that the data would be unambiguously interpreted. So the data get posted on the web, and the metadata follows the prescribed format. you'll see in a moment that even though these are the principles and goals, we had to start with some first steps. And so this isn't describing what currently exists. These are the principles and goals of the system, although for some data types this does work. So that would allow these data files to be easily harvested by a central data portal. And so the idea is that, you know, it makes it relatively simple at the site level, makes it relatively easy for scientists to comply, and I guess addresses one of the common choke points. So here's kind of a schematic description of the system. Every CZO has their own data system, whether it's a relational database or a series of flat files or whatever they do locally, and they post files onto a web accessible folder that, whoops, wrong direction, that then gets harvested, archived. Well, the metadata gets harvested, archived, validated against shared vocabularies, fit into a CZO metadata standard that follows an ontology, which is kind of a hierarchical representation of concepts or vocabularies. Oh, I keep on going the wrong way. And then on top of all that, delivers what we'd call standard CZO services. And I'm going to describe what those mean in a little bit. But essentially these services and this whole package kind of that I just highlighted in orange is what really comes together as our CZO Central Data Catalog. And that catalog can then be queried by various desktop applications or others to get access to the data. The data itself is not stored by the central CZO system. It's always stored locally. The central system is really a metadata system. So that therefore enables discovery, data products that would then feed back into the system, and then registration with other systems, such as what's being developed by LTRs or as listed here, DataNet, Neon, et cetera. So this concept follows kind of the golden triangle of cyber infrastructure, which is that there's a place where the data is stored, the data server. There are catalogs that essentially index what is in the data server. So you can kind of think the web actually follows the same idea, right? Individual organizations and people have websites with content. Google and Bing and others catalog what is there. So anytime a client who wants to find out what's out there on the web or in the CZO data repositories can basically go find out what's there from the catalog. The catalog is a big index, and then once they get that information, the location essentially of the files that they want to get, they can then go get them from the data server. So, whoops, got my backwards again. So essentially what we have is that these, the catalog and the data server are both databases, but in the case of the catalog is not, does not actually store the data values. It's kind of everything but the data values at some level. And then each of these arrows represents a metadata transfer, or these two arrows here, but then real data transfer happens here from the data server directly to the client. So it's, again, the client might be analogous to the web browser that searches Google, that then provides the URL so that you can go get the web page that you're looking for. It's kind of the same analogy. The whole web is built on this. So for our case, we've got the metadata catalog, which is at search.criticalzone.org, data server at each CZO, and then a client could, be someone just using a web browser to download a file, or their software, because all of these systems can be very automated, software such as Quasi-Hydro Desktop, which can go do some of this searching behind the scenes and data retrieval behind the scenes. So at search.criticalzone.org, this is our central CZO data portal. It looks like this if you go to the website, search.criticalzone.org. And it's really very no frills. It is what we have right now, has long been criticized, and rightly so, for being not all that useful. And unfortunately, until relatively recently, we didn't have the kind of resources to make a fancy front end there. But nevertheless, if you know what you're doing, you can go in here, search, and get information like this. What is a little bit challenging, actually anybody can go and search, but what's challenging is that what gets given are just metadata profiles. So actually, you have to dig into the files, read them, find the URLs to the actual data, and then paste those into a browser and get to it that way. So it could be better in terms of its user interface, but what's under the hood is what's important, and then that is a really robust metadata cataloging system that's built on GeoPortal, which was originally developed by Esri, the makers of ArcGIS. It's a geographic metadata cataloging system that uses international standards. And Esri actually open sourced the software, Open GeoPortal, and that allows, that's been a great move. But these GeoPortals can actually be federated or register between themselves, so it allows interoperability between data systems, which is really quite nice. So you know, a little bit more into the details. The portal is what's called Catalog Services for the Web Compliance, and I already mentioned the ability to federate these with other data catalogs. It supports searching by location, et cetera, a bunch of search capabilities. And then here is kind of the second reference we've seen now to display files. And I'm going to jump ahead and show what a display file is. So the CZO display file, and I'll qualify that by saying this is version 1 that was developed in 2010, was kind of given the requirements by the CZO PIs at the time of the original first CZOs, actually with a lot of input from Mark Williams, based on his experience managing the Niwa Ridge LTER, is that they should be human readable and machine parsable, which is kind of a tall order because a lot of machine parsable data in XML, for example, isn't very easy for a human to read or use unless they are a sophisticated computer user. Whereas a lot of the human readable files are not so easy to parse by a machine. So another component was that we wanted to use this, or I say we, I wasn't actually part of the original decision, but the group that wanted to use this to begin to automatically parse these files into Quasi's Hydro Information System. Basically, anything that would fit into Quasi's Observations Data Model 1.1 and could be tagged with Quasi's Shared Vocabulary, and I'm going to talk about that a little bit. We now have a CZO Shared Vocabulary that was built off of that. Anything that could fit into that could be posted as a CZO display file. So the solution was, it would be ASCII text, basically a CSV ASCII file, but with a very special, a well-specified header that details metadata, basically what's in the file. And then to kind of expand on that, every CZO would have a separate file that would describe the sites where they're collecting data and the methods that they're using with which to collect the data. And the specification for the CZO display file format version 1 can be found at criticalzone.org, again under national publications that are have the metadata or the data cyber infrastructure tag on them. So I mentioned the CZO Shared Vocabulary. That's available at sv.criticalzone.org. It was built upon the Quasi Master Controlled Vocabulary Registry. It was basically cloned from that. But then Mark Williams felt very strongly that, and the other CZOs too, was that the CZOs needed their own vocabularies. So it's no longer perfectly aligned with Quasi. That was just the starting point. The system actually allows, if you go to these different vocabulary types, the system allows one to propose changes, to make edits, it serves a little bit like a wiki. You can say, well, this variable isn't listed, so let's get it there. But nevertheless, the structure of the shared vocabulary is more or less conformant to Quasi shared vocabulary. So a shared vocabulary system is basically, just to back up a tiny bit, it's basically to make sure that everyone spells a variable or a unit the exact same way, so that nitrate, there's a dozen ways to spell nitrate, the concentration of nitrate in water, and there are probably nearly a half dozen or more units in which you could represent how the nitrate is there. So that combination can explode. So to get everyone on the same page, instead of making up your own, deciding your own spelling of the variable nitrate, you look it up in a list. So these are basically lookup tables. So backing up, so the CZO display files are one of the many different file formats that can be cataloged at CZO Central Catalog. To do that, data managers have had access to essentially a CZO data management web administration interface through the website central.criticalzone.org. And essentially, you have to have a login. It's for data managers only, and they can go in there and register display files. They can register any other kind of file they want. They can initiate more sophisticated data retrieval. They can validate against control vocabularies, etc. The truth is, and this is something we discovered a year ago, that a lot of the data managers weren't really using that. It's certainly not as effectively as possible. There was probably a lack of training because money was tight. In practice, most of the CZO, the local staff members at each CZO that was in charge of their CZO's data would primarily use this to just register display files. So a lot of the data that CZOs were producing were not really getting into the system as well as we'd like. So rather than spend a lot of time trying to train everybody how to use this system, we actually proposed an alternate system, which is based on using the new website at criticalzone.org, and I'm going to describe that in a moment. So this is still all functional. It's just it's going to be deprecated or retired. This back end. Actually, the back end might still be there, but it will be no longer be the preferred way to get data in. That's in the process of changing. This just shows a little bit of the kind of control that a data manager can have at that back end. We're going to talk all about this in a good bit more detail in our third cyber seminar, which is the next Thursday. We're going to have 2 next week to try and move quickly through this, because I know a lot of CZOs are chomping at the bit. So with CZO display files, which are a very special type of file because it's this agreed upon format, not only does posting that CZO display file in the specified web accessible folder for the CZO, not only does that ingest it into this data portal that we described, but it also triggers a parser, because we said we wanted to be able to parse this, and it parses it into a Quasi observations data model database, which then enables a WaterML web service that gets registered here as a web service, not just a data file, but a web service, and we'll talk about web services a little bit more. But that web service then basically can work its way through the cloud and become part of the Quasi Hydrological Information System, HIS, catalog, because it can get federated with other catalogs, which it does, and it enables data that's been pushed through the system and that parses properly without any errors to basically become available in Hydro Desktop. I guess this is kind of labeled CZO Desktop. There was an idea at some point that maybe the CZOs would create their own version of Quasi's Hydro Desktop, but that idea has changed a little bit. So that describes the kind of the system that we have in place now, which
can we make a quick clarification?
Yeah.
David Levinsky. That last path that you were talking about?
Yeah.
And in that case, it's not just metadata, right, that's being harvested. In that case, data is actually being harvested.
That's true. Slight clarification. Yeah.
I just wanted to make that clear because you've been concentrating on metadata in this case.
Yeah.
It's kind of a big distinction in some ways.
That's right. So the main purpose of CZO Central was to harvest metadata, to be the search catalog that can be federated. But if the file that gets posted is a CZO display file that parses without any errors, then the data will also get harvested. And this little database right here is actually a Quasi Hydro server that has been installed for the benefit of each CZO at San Diego Supercomputing Center. So the CZO data managers themselves never have to get anywhere near a Quasi Hydro server, but by posting their data as a CZO display file, their data can get ingested into a Quasi Hydro server, and there's one for, on a virtual server, there's one for each CZO. Well, I should say each of the 6 first CZOs, and right now as we speak, Tom Whitenack at San Diego is installing them for the 4 new CZOs. And by doing that, there's all the software built on a Quasi Hydro server, then it allows all these other kind of more automated communication to happen. So the person who spoke up was David Lubinsky, and I didn't actually include him on the credits or the project team initially because he wasn't really explicitly part of the project team on the first round of funding, but he is our web person. So he's the one who's created the platform for criticalzone.org. And that was kind of somewhat of a separate project in the first round of funding, but now it's becoming much more integrated with data. And so I should go back to that first slide and put David Lubinsky's name on there because he's now an important part of the data management, the national data management team. Okay, so I wanted to look at this figure again because these arrows, when done by software, are done by what's called web services. And I think there's a lot of, people mention web services, and for those who aren't, immersed in the world of cyber infrastructure, they might imagine, some utility that's on a website somewhere so someone can go do something, right? Some tool, web tool. Web services actually is a little more specific than that. It essentially refers to methods of automated communication between 2 electronic devices. So very automated. Here's this golden triangle of the web right here, and it's describing the different types of automated communication protocols that works between, in this case, this is somewhat a mirror image of what we saw before. This is the catalog, this is the server, and this is the client or the service requester. So, so there are relatively simple commands that move data around, and most of the data that's being exchanged on the web right now is being exchanged in extensible markup language, or XML. And this is what it looks like. It essentially tags values so that it's really clear that Sanguinaria canadensis is a botanical term that that describes that variable, botanical variable. And so it's very unambiguous, and these can be validated versus prescribed, what they call schema. JSON, or JavaScript object notation, is a leaner, lighter weight approach for sharing data. It doesn't have as long a history of being used for general web communication. However, it's much more compact and it's much more human readable. So there's a lot of movement toward using it increasingly for data transfer, not just for kind of web metadata, but actual data because of its compactness and human readability. All right, so you might have heard of WaterOneFlow and WaterML 1.1. WaterML 1.1 is just a specification document that describes how to use XML to transfer data in and out of QASI's Observations Data Model 1.1. So WaterOneFlow is kind of the general web service interface, and WaterML is the actual XML schema that transfers the data. WaterML 2 is actually now a standard of the Open Geospatial Consortium. And I'm sorry I didn't spell that out. Open Geospatial Consortium, or OGC, is a term that you should become familiar with because it is becoming, it started out as a body that was interested in open source and open data formats for GIS, or Geographic Information Systems. But it is becoming increasingly an international governance body for data standards. So WaterML 2 was basically the attempt by QASI to get WaterML to become an international data standard, and that's been done. It was specifically a profile of observations and measurements, and again, I'm sorry I didn't spell that out. I actually did in one version, but I fortunately had a crash of PowerPoint just a few minutes before I started here. So observations, Open Geospatial Consortium Observations and Measurements. You're going to hear that again, and it's shortened as OGC-ONM. So apologies for that acronym. Part 1 is fully implemented, and part 2 is being proposed right now, and part 3 is sometime on its way in the pipe. All right, so that gives a little bit of the background about what exists now, what was really accomplished in 2010 and more or less finalized by 2011. Any questions? All right. I will move on to the next part, which is kind of where we're headed. All right, I see we have a good number of people here now. All right. So in December of 2012, the second round of funding for CZO data management was funded. The money didn't actually come until March of 2013. So actually this slide probably needs to be updated. It had 5 major goals, and it is much more generously funded than the first round of money. Essentially, what was accomplished with that first bit of money, and because of other initiatives within NSF, Enriqueta was able to secure a pretty healthy amount of money to fund this data management project. So the first bit is about community to support interaction with CZO PIs, scientists and data managers, essentially this information management committee concept, trying to really get people involved, not just data managers, but also investigators. We wanted to have a much more uniform web appearance for individual CZOs in the national program. We wanted to further development of consistent metadata. We wanted to enhance the workflows or make it easier for CZO data managers to share their data, and so that it could be more easily discovered by CZO investigators. And our original workflow was completely built on QASI hydro information systems, but we realized that captured really just a small fraction, an important one, but a relatively small fraction of all the data needs for CZOs. So we took the next step that was logical, and that is to try to create interoperability with the Chem project that is being managed by Kirsten Leonard's group at Lamont Doherty Labs at Columbia University. We wanted to make it easier for people to discover their data, that is to put a nice user interface on search.criticalzone.org. And then we wanted people to, investigators and others and the general public, to be able to visualize that data much easier so that it didn't require downloading the data to see what was there. You could actually have an idea of what was there right from a web browser or some other client. So here's the architecture. It's a little bit different, but again, the CZOData project basically has its group of services that are really all about taking the data that are still going to be stored at local CZOs, and still the major services are going to be provided by other data centers, not CZO Central. And what we're doing is kind of acting as a middle layer to enable the data to more easily get into these other systems, and then develop a web portal so we're kind of, I guess we have two aspects here. The CZOData is over here and over here. So we're also going to try and make it much easier to visualize and discover the data in that system. Oh, my animation is wrong here. So here are those, here's what we're doing now, and for each of those 5 major categories. So for community engagement, I think you've already, of course, a lot of you are here because you've signed up to participate in this information management committee. So I won't spend a lot of time on that. But I will say a little bit. First of all, thank you all for being on the call. I think it's really important that CZOs share with each other the challenges and solutions to those challenges that they find in this process. Right now, the world of cyber infrastructure and data management is moving very rapidly, and of course, the data that is being collected is expanding at a crazy rate. And so there are no super easy solutions right now, although big initiatives like EarthCube and scientific software efforts, development efforts within NSF will hopefully deliver that in the next 5 years or less. Actually, hopefully a lot will happen in less time than that. So anyways, those are all important reasons to share and interact with us. But also the other purpose of the Information Management Committee is to really help develop, kind of co-create the metadata requirements and the shared vocabulary that we will need to share our data in a unified way that would enable, which is the foundation of interoperability, so that one could do cross-CZO data analysis. So the CZO data team, project team, is not the right group of people to develop those requirements and shared vocabulary. We can guide it, but it's really up to all of you. And then kind of the other bit is to put in front of us data use scenarios that may continue to represent challenges despite what we are developing. All right. So the next big challenge is to get data on the web, basically to get data what's known as being in the long tail of the curve of scientific projects out of the dark, because I guess I'm referring to a description, and I probably should have given a little bit of a slide describing this. But a librarian by the name of Brian Haydorn published in 2009 or so a paper that really caught the attention of a lot of scientists, and that is that the majority of science projects are quite small. And in fact, even though a lot of attention is being paid to, really the big projects that are being funded, these smallest projects are still the majority of the money that comes out of the National Science Foundation. However, because they're small projects, they have no ability to fund big cyber infrastructure efforts themselves, and no dedicated data managers, and their data is much more heterogeneous. And as a result, these projects that are in the long tail of science, really their data has historically remained in the dark and not exposed to the public in ways that it could be reused. So that has really motivated a lot of what's going on with EarthCube and some of these other initiatives. So we want to help the CZOs get that long tail data out of the dark. And as I mentioned earlier, we realized that the CZO central catalog, even though it had the capability of putting metadata tags on any file, Excel, GIS files, proprietary geophysics instrument files, any data can be posted on a CZO's web server, a web accessible server, and get cataloged by the CZO central catalog. Any of those can be done, but very few CZOs were actually doing it. So we wanted to make that a whole lot easier. And what we came up with was that we'd leverage the nice website that has been developed at criticalzone.org. So originally the scope of this website was to just to have a shared web outreach platform, and that data was still going to be presented completely on local CZO web servers. But and the original CZO PIs were quite insistent that that's how it should be. But by 2011, 2012, the greater community, the CZO steering committee, and NSF was basically saying it's too fractured, it's too heterogeneous. Even if you guys do have these, fancy web services in the background, most of us still want to just browse through your data sets on a website, and most of those websites look completely different from one another. So let's unify them. And so that's what we did. So we spent quite a bit of time in the last year developing the data tabs for individual CZOs and developing what's now called a data set page, which looks something along the lines of this. And so it's essentially a data set title, an abstract or description, some keywords, the variables, who made the data set, and then at the bottom, links to files that actually hold the data. So what we realized is that if CZO data managers and investigators filled out this information on a nice homogenized web system, that this could actually serve, all of this information could serve as a metadata profile that could be automatically ingested into the CZO central data catalog. And we realized that the data managers had already become comfortable with using the website. At the back end of the website, there were lots of capabilities that were really nice because it automatically allowed tagging of authors and field areas and these disciplinary tags that we developed for the website. So there was already a lot of information that was very easy to get your fingers on built into the website back end. So let's use it for these metadata profiles at the catalog. And so that's the decision that we made about a year ago. Whoops. But we had a lot to do to just develop these data pages. That's been completed, and now David Lubinsky and the folks at the San Diego Supercomputing Center are right now building that automated system to transfer the data. So we're going to move away from using that admin panel, although right now it's still possible to use it, and move toward doing it all at criticalzone.org. Again, the data aren't being stored here. These files are just URLs to files still being hosted on the CZO data servers. However, as David Lubinsky pointed out a moment ago, if the file is a CZO display file, and there's a little button to click on, it will be ingested, parsed and ingested into Quasi's hydroinformation system. So this is a pretty nice concept, and we feel really quite good about it. The development of that automated harvesting system has been put on hold a little bit while we get the new CZOs up and going with their main website. As soon as that's completed, then we'll move ahead and complete the automated metadata transfer and harvesting. In the meanwhile, the new CZOs and the existing CZOs can continue to load these dataset pages online with the assurance that eventually all that information will be harvested into the GeoPortal. And when I mean eventually, I'm talking about like in the next 3 months or something. That should be highly functional by then, maybe even sooner. All right, so now we're moving on to this metadata and basically coming up with a CZO shared metadata approach. The solution that we've had is to extend our integration with the Lamont Doherty Columbia University Integrated Earth Data Applications Group and CSAR, which I'll describe in a moment, and then also leverage a sister project that's been going on, independently funded, to develop a new data model that could be used for essentially nearly the full range of critical zone data uses. And that's a very exciting project that has had an intense amount of activity in the last year. And I'll describe that in a moment. So CSAR is the System for Earth Sample Registration. It is an international. It is part of the international body that oversees the International Geosample Number, or IGSN, which provides globally unique codes for any specimen that one brings out of the field and into the laboratory, whether or not it's a Marine Corps, which was the primary use case in the beginning, to any other type of geological specimen, or including, in fact, the geo here, I think, could be more broadly interpreted to not mean geological, but more geospatial. So what's important here is that the location on the Earth where the specimen was collected is being recorded. So these international geosample numbers could be equally well used for biological specimens, including you know, some bird that you met and stuff and stick in a museum could get an international geosample number associated with it for specimen archiving and management purposes. So in our proposal, we said that we would develop a registration system so that the CZOs could use international geosample numbers. I'm going to describe to you why that is important. In a lot of our use cases, and we're looking at the use case that was developed by the original use case for CSAR of marine sediment cores, that this could equally be thought of as a soil profile, or even something like a tree. You know, you could basically, you have a specimen that you pull out of the critical zone, and you might section it spatially. You might then take those sections and subsample them in very equivalent ways, and then you might do another level of subsampling in which the subsamples are not equivalent. They are actually separate or fractions or extractions of the original sample. And so this hierarchy of parent-child relationships between specimens is incredibly important for what we do in CZO science. And the ability to give a globally unique identifier to any of these enables CZO teams to share specimens between each other within a team, or between CZO teams, or with any other outside collaborators and always be able to trace the full lineage of what is related to that specimen. So not only if you know this specimen ID, this core section ID, do you know where the parent core was taken from, but you can also use the CSAR system to find all the other specimens and potentially the data collected on all those other specimens that all originated from the same core or the same site. So the benefits are really clear to, they've been so clear to the marine community that international geosample numbers have now become the de facto standard for marine drilling programs. And we're going to be rolling them out as the standard for CZOs. This is just an example of the kind of really messy fractionation schemes that I think a lot of the geochemistry labs in the CZO program use. But again, you could think of this as a tree, the different sections of the tree, whatever it might be, the samples of tree rings or individual leaves or whatever it might be. So this can work equally well for biological specimens. The next bit is the Observation Data Model 2.0. And as I mentioned earlier, it's a project conceived to come up with the next generation observation data model that will be the foundation of interoperability. Even though we use the name Observation Data Model that was used by CWASI, the intent is to be equally useful for AIDA, EarthChem, CWASI, and other data systems. And in fact, key partners on this are the folks at EarthChem, and the infrastructure that's underneath EarthChem and even the Marine Geological Data System is being rewritten right now to build upon what we've discovered with Observation Data Model. It will be essentially their systems will have the exact same capabilities as us. So that's really exciting that EarthChem and CWASI HIS and other data centers are committed to ODM2, and because they'll build their infrastructure around ODM2, the interoperability will be quite exciting, it will make a huge difference. So the system will have better support for identifiers, extensibility, better annotation and provenance, and support web services. Let's see here. This slide is a little bit of a review, and it may seem very basic for some folks, but we're on this topic of metadata, and before I get too far down into describing ODM2, I just want to really make sure we're on the same page, that there are two types of metadata, and some of them have to do with making sure that you all share the same vocabulary, that nitrate is spelled the same way, and that the unit for nitrate is spelled the same way, and that maybe there's even automated interoperability between units. But then the other one is the choice of fields that you use in the data model. So I'm going to describe a little bit about what a data model is. And again, this is going to be really basic. But most of us in the very beginning organize our data in tables, or what are flat files. And they're flat because they're two-dimensional. All the information is stored there, but you can see that a field or attribute of this file may be very redundant for many samples. And really all that's changing here is stream stage, and yet this is and date time, and yet all this other information is repeating for every record or row of the data file. So one can take all that information that repeats and put it in another table. So it's much, much more efficient. So all this information about the station name and its location gets typed in once. So not only is it more efficient in terms of storage, it's much easier to repeat this integer than it is to repeat all of this, but it also eliminates or massively reduces errors in how this gets repeated, because maybe pump house gets repeated over and over again, but one of these digits gets transposed or something, and then one has to figure out, well, which is the right one. So there are two huge benefits to that. This, what they call normalization of tables, so and the relationship between the tables. So the first column of one of these tables is called a primary key, and then where that primary key is referred to in another table, it is then serves as the foreign key to the primary table. All right, so that's pretty basic. I'm going to skip over that because we talked about some of this. So clearly the shared vocabularies are important. We talked about that. And now I'm going to talk about why information models are really important. I feel like information model is the underappreciated aspect of common metadata. So here we have the golden triangle of data services that you saw before. What sits at the center of all of this is an information model. It says, well, what information are you sharing? And it is really important that the data server, the data catalog, the client, and these metadata and data transfer schemas all share the same information model. If they don't, the only information that can be automatically shared is the information that forms the least common denominator between the data models. So if you don't share data models, there's loss at every one of these transfers. And we don't want that. It turns out that Quasi's system, that's built very much like this, started out with an information model that they wanted to share. It was implemented to the data server, but then there was realizations that it wouldn't work very well for a cataloging implementation. It didn't perform well enough, and similar things were said for the client. And then now there was a realization that even to conform to international standards and become OGC compliant, that the metadata transfer had to be different. So Quasi's current hydro information system actually has a different data model for all four of these purposes, and there's a need to change that or improve on it. So the observation data model said we're going to have a core set of tables with the required fields or potentially optional fields, and then the ability to extend that in for other purposes. So that would allow then these common semantics for all these different data systems. So this is a brief look at that. I'm not going to go into it in detail. I just want to explain what this is about. We're going to spend a whole cyber seminar on Quasi ODM2. So I'm getting close to the wrap up here. I know that I've gone on for a little bit of time here, and I apologize. I wanted to give a whole system overview, and I guess there's a lot to pack. We're going to get into the details later. So the next challenge is basically building tools to enhance the data management practice of CZO data managers and also investigators trying to use that data. One of the things that we need to do is to take this display file and basically update it. Not only because the current one, is due for an overhaul because of little issues that have been discovered over the last couple of years, but also because it really only serves the use case of publishing time series data to Quasi's current hydro information system. A lot more can go in there than hydrological data, but it's still quite limited. So we want to create a new display file version 2 that's built around ODM2, again, shared data model, and also built around more standardized and web standard formats such as JSON, JavaScript object notation, for example. We're going to talk about that on a totally different day. The next one is that we want to build extensions or tools around ODM2 that assist data managers for doing things like sensor and instrument tracking, sample tracking. We're going to discuss that in the ODM2 cyber seminar, but there's actually money that was funded by a separate project called the Big CZ SSI, and specifically the toolbox for doing just that. And I'm going to talk about that a little bit later, but Big CZ is an acronym for Biogeo Integration for Critical Zone Sciences, and it was funded by the NSF Scientific Software Integration Program. Okay, so, and then our last bit is to develop a web-based data discovery and visualization client. And what we have money to do right now, and have now built the background infrastructure to begin doing this, is to adapt the NANUS visualization system for CZOs. And there's the URL for what this might look like. And essentially, here's a screenshot. This is actually a functional website, although it's built on some relatively old software versions, and it's sitting on a really old and slow server. For this kind of this map-based data discovery and download capabilities that I think would really benefit the CZOs. We're going to talk about that later, but it allows some very simple search and discovery. It's all built on the cyber infrastructure background that we've talked about. You don't need to download anything like Hydro Desktop, and we are going to try and eventually get this to work for all data types. So though initially it is going to be focused on time series or data series. So I think we're going to be able to get SOA profile data in here too. But we'll see. We'll talk more about that later. So essentially, this is my last slide. It's just an overview of what this Big CZ SSI project is. It actually was started on December 1st, 2013. This is an old slide. Has the goal of further community engagement, building a web portal, which is actually not what I just described. This is going to be deployed for every single CZO in a kind of a custom application. The Big CZ SSI is going to fund a portal that works everywhere in the United States, actually. It's going to be quite big, and it's going to sit on top of high-performance computers. We're going to build this toolbox, and then a much more robust central system for interoperability that bridges not just with Quasi and AIDA's EarthChem, but also with some of the biological systems, such as Data One and the LTER system. All right, so there's the huge overview. Any questions? I know we've now gone for an hour exactly. I apologize for the length. I've got my chat box in front of me if anyone wants to type anything, or you can unmute yourself and holler out. Nothing? All right. Well, if we're going to have the next cyber seminar is going to be in next Monday at the same time, and then we're going to move to Thursdays, starting the very following Thursday. So 4 days later, we're going to have the third cyber seminar. The next cyber seminar is going to focus on why data publication should be done. Kristen Leonard's going to lead that presentation, and it's going to give some motivation a little bit more about why sharing data needs to happen, and then how to do it with a capital P, that is to actually get it citable with the DOI and really get it into these data sets so that they can be considered products by NSF on your CV or on any other CV. Hopefully that's the way things are moving. And we'll give some examples about how to do that and actually have some walkthroughs. So half of it's going to be a walkthrough on how to get DOIs and register data sets and load them up onto into these data systems. And then that following Thursday, we're going to then have the web team show how to create a data set on the CZO website and how that gets registered in the CZO data portal. So so there'll be lots of hands-on activities and discussions. So
Anthony, I have a question. This is Miguel Leon from
Hi, Miguel.
CZO. Will the ODM2 be reverse compatible with ODM, the original version, or would it be a changeover?
Absolutely. So that kind of compatibility is quite important. And in fact, this afternoon, I'm flying to Utah State University. We're going to spend the rest of the week, the whole ODM2 team, presenting our data use cases. And for Jeff Horsborough, his data use case has essentially been translating between an ODM 1.1 data system and ODM2. So there will actually be automated systems for that transfer. There will be SQL scripts that will allow you to do it, and there'll be web services eventually that will make that seamless.
Great, sounds good.
Yeah, and we will not be telling anybody to redo their old CZO display files, but we will be strongly encouraging people to migrate to the new format once we've specified it. But we will not fully specify it without your input. So that's part of the process that we want to really roll out this spring.
Cool. Sounds good. Appreciate it.
Yeah. All right. All right. I have a question from Tyson, who says, you know, how can we learn more about this? And I will be posting on this Cyber Seminar webpage links to, why don't I get out of here and see if I can, let's see, oh, I gotta escape out of PowerPoint. At criticalzone.org, I created a web page for our cyber seminars. Let's see, put those on top of our screen. This is not it. So our cyber seminar, oh, I should have clicked on that one. Let me do that. There we go. So right now it's under browse by data. Okay, so at this website right here, this 2014 CZO Cyber Seminar Series, it has links to the WebEx meetings. I'm going to be updating this regularly, a couple times a week. And as soon as I can, I'm going to put links to both the PowerPoint and to the screencast or the recording of this video right here. You know, I'm going to basically change that and say via WebEx. I'm going to say, you know, watch the video or download the PowerPoint, and that will be right there. And so this will be a dynamic page that we'll be updating, including the schedules for these other seminars as we harden those schedules. All right. Any other questions, either via chat or just jump in? I'll say one more thing for those who are interested in ODM2, and I don't think I mentioned this or provided the link on my slide, and I apologize, is that we are developing ODM2 in GitHub, which I think some of you are probably familiar with. It's now becoming the main go-to place for open source software development. And in fact, it is phenomenal for collaborative development of just about any electronic files, especially those that are open like text files. So we are describing ODM2 here. You can dive right into these diagrams and explore the ODM2 field. You can click on tables and learn about all the gory details about how this might be implemented in a database. We are also exploring, I might have clicked through that a little quickly, we're now taking the database implementation and translating it into UML, Universal Markup Language, which will drive XML schemas and other things. So there's a lot going on here. There's a really extensive set of documentation about how to use ODM2. So if any of you want to dive in and see what's coming down the pipeline, you're welcome to go to this GitHub site and read all you want, and actually you can even download XML schemas right now. We will be loading up actual dump files for SQL for databases and everything so that you can recreate databases using ODM2, but that hasn't happened yet. Anything else?
Just a short question. This is Marion Massey from IML CZO, Illinois, Iowa. And as we discussed before, there are various levels of preparation infrastructure which we have locally, and now I understand that we will have to have a minimum of adopted common protocols and so on. So for metadata and other things, formats, how do we go about this? I mean, this is the first meeting which I attend. I didn't attend other, CZOData meetings. So is there an agenda for getting this information and, getting advice? And I just try to see on the practical, in practice how this transfer of information will happen. In CZOData, local CZO.
Yeah, sure. So we will be, these cyber seminars, we're planning on doing walkthroughs of all of these processes, especially in the next few. The next two that we've scheduled are going to be very much tightly related to describing the protocols for sharing data, basically how to share data now. We will then have these additional discussions about where we want to go in the future. The current system now, that was again developed in 2010, 2011, has relatively limited applicability for the full range of CZO data types or critical zone data types. It's really, like I said, hydrological time series are well supported. Other types of time series, very limited sample-based data, as long as you don't have any complicated sample metadata. All that is supported right now by our current version of the display file. If you want to find out how that current version works, you can go to our criticalzone.org, to the national tab, and hit data and look at data activities. And this, and I probably need to update it, but this right here describes how, it provides links to the current display file specification, the shared vocabulary system, the links to the data portal, describes what's been done. There is, and I do need to update these, and because there have been an enormous amount of developments in recent months. But then the next tab, Cyber Infrastructure Development, describes where we want to go. So again, activities, what has been done, and development, where we want to go. My suggestion for the new CZOs is to hold tight, because a lot is going to be changing in the next couple months. We will be developing together approaches for managing shared vocabularies. The current shared vocabulary system is too limiting. We're going to be migrating that to GitHub, most likely, although we haven't fully acknowledged that, and expanding it quite a bit. But also, we're going to be saying, again, we can't reinvent the wheel. So the new CZO display file format will actually allow one to use shared vocabularies from almost any shared vocabulary registry that's online. So you could say, I'm using the quasi-shared vocabulary, and we'll be able to handle it. Or you could say, I'm using the CSAR shared vocabulary or the EarthChem shared vocabulary, and we'll be able to handle it. We are also going to probably try to create a CZO shared vocabulary. That will be a little longer process, but we actually think might develop into a really nice product that's a little more conceptually consistent than trying to, trying to squeeze on the undersized or oversized shoes from some of the other CZOs, or from some of the other data systems. Actually, undersize, oversize isn't the right one. It's really kind of different, totally different shapes, right? So we are going to be developing a new shared vocabulary system, and the CZO display file is going to be revamped with input from all of you.
Okay, we'll be around.
All right.
Thank you.
Great. Yeah. Any other questions? I see that Ilya Zaslavsky is on the line, and Ilya, jump in, but I'm going to say some things that you know a lot more about than me, so please jump in to clarify. But we know that some of the new CZOs have quasi-hydro servers that are already set up. So it may seem awfully inefficient for you to produce CZO display files that then ultimately creates a lossy data transfer back into quasi-system. So Ilya's team, Tom Wojtnak and Ilya, can essentially help you set up a web service, I'm sure, to automatically share that data directly into the CZO central catalog as a service, and also into Quasi's hydro system. Ilya, you want to pipe in?
Yeah, that's correct. So you have a range of ways of how you can publish data. One, as I said, as essentially said, is display files, or what would be certainly preferred is if you host a quasi-hydro server, and then you will publish in these data as web services, and we will be harvesting them into the system. So I think that second route is preferable, but you certainly have options. In any case, at this point, this applies to hydrologic time series only, and hydro server will probably stay focused on that. But the display files mechanisms will provide, eventually, once ODM2 is finalized, a more general solution when you can present data about any types that you handle in CZOs, and we shall be able to harvest them and trace.
Yeah, so if you do have Water One Flow web services, either in a hydro server or elsewhere, I would encourage you to contact Ilya or Tom. And again, if you go to our CZO website here, somewhere, there are links to the data team. So, well, probably the easiest way to go is the National People. And if you click on National People, there are not many. There are a few folks who kind of are listed here as kind of the main contacts, and then the principal investigators. But most of those people with the national role are the data management team. So there's information to get to Tom and Ilya there.
Okay, we have to take some decision locally because we are also mixed in terms of infrastructure here. But anyway, good, I got the information to be discussed here.
Okay.
Thank you.
Yep. Yeah, I think I'm going to describe. I'm going to qualify my answer a little bit. I think if you already have Water One Flow web services, the best thing to do is to register them at so that they're available as a service at searchcriticalzone.org. However, I think for consistency, and we should all discuss this, there is a large, so this is search.criticalzone.org, so you could have the service listed here. I think there's still an interest in having those files essentially created as CZO display files or posted so that they could be eventually archived as files, or that so other people could access that data by downloading files, because unfortunately that's still an important way that a lot of people access data. So what the difference is that if you already have a Hydra server with Water One Flow Web Services, you wouldn't actually feed those services via the display files. You'd feed them directly from your system, but you'd still load up the display files. But new CZOs don't bother producing display files until we come up with the display file version 2 specification.
Yeah, as Anthony said, display files and services have distinct purposes. One of the reasons for coming up with the display file mechanism was that NSF and Mark Williams were pretty had pretty strong opinion about letting anybody who would want to get to the website trap the data in the most readable and understandable format. And that, of course, is ASCII, and with some reasonable formatting that closely follows how LTR formats data logger files. So this is essentially what display files for hydrologic time series look like. And the purpose of services is different because services can be called from applications, and you can build mashups and visualization clients and analysis clients from the services much easier than you would do, of course, over ASCII data files. So the reason for having this perhaps a little convoluted system is to be able to expose the data on the web in the least common denominator readable format, and also provide like value added republishing of the data so that they can be used in applications.
Yep.
All right. Any other questions? All right. Well, thank you all for joining us. I see we have quite a list of people here. I wasn't able to type down everyone's name, and maybe we'll do that as we go forward. I will create a Google Doc that we can use for recording notes, perhaps, and everyone who's attended. But we have a nice, healthy turnout. That was great. Really appreciate all of you turning out. And hopefully these will be useful. We're very open to suggestions on what to cover as we're moving forward. So the next two are more or less set, but again, at this website right here. But after that, we're quite open, and we basically want to move quite quickly into questions of shared vocabulary, display files, and sample management. But probably needs to cover ODM2 a little bit before we do that because it's so foundational. But the next two seminars are really all about how to start getting things done right now, which I know many of you want to do. All right. Thank you.
Thank you.
All right.